The Pathways to Knowledge model of information processing identifies 6 stages that students go through when learning to process information. They are appreciation, pre-search, search, interpretation, communication, and evaluation. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class are learning about the properties of sound. The school library media specialist collaborates with the teacher on the sound unit. She guides the students through the pre-search stage of information processing when she conducts a mini lesson on how to use the University of Michigan's Artemis Digital Library. First, she has the students brainstorm a list of other searches they have done in order to help them relate their new assignment to previous ones. The students will search Artemis for information on the properties of sound in order to build background information for a class discussion. The media specialist helps students define their information needs and identify keywords that will help them find the information they need.
Well, while we're waiting for that, let's brainstorm about how you do this. One of the best features about this database is that it cuts right to the chase. If you have a question, you can enter the question directly. You don't have to worry about Boolean searching. Remember Boolean searching, where you have to say dogs, not cats, or cats, not black cats, to find the exact specific information you need. This functions like a natural language search engine. Does anybody remember what that is?
Yeah, you type in a question.
Yeah, you can just type in a regular question, and so you'll be able to get the most specific results if you type in that question. What would happen if you typed in the word sound instead of the question? Would you have a lot more sites, or would you have fewer sites? You'd have a lot more sites. So what if you were a person who hadn't decided exactly, maybe you were going to try to look at if animals hear things differently than human beings? Which one of those would you type in? Let's try both ways that we talked about before. Let's enter our question that we have come up with. What was our question?
How does sound travel?
How does sound travel? Let's type that in the search box. One of the things I think we should do is let's go and do sound. Let's erase how does sound travel. I want to just quickly give you a comparison of the kind of websites that'll come up. You didn't know exactly what you're going to do, you're going to go for the broad term, right? And this is also going to show, I love this. It gives you a lot of help. This website will allow you, look at animal communication, frequency, that's another word associated with sound, linguistics, vibration, waves. All of those search terms are going to help you. So you can search on Artemis with those search terms, or also you could jot them down and search on general search engines. Look how many more websites that we got when we just typed in sound. Okay? Okay. All right. That's it.
Great. Thanks.
That's how we use it. It's a helpful site.
The students demonstrate the search stage of information processing as they use Artemis for cooperative searching. Pairs of students select and use information tools, websites in this case, to find information about sound waves. They skim and scan to gather information, and they record notes in their composition books to share with their classmates later. The teacher encourages the students to find information that is interesting to them.
What we've talked about is velocity, right? The speed of sound, okay? All right, so there's your speed of sound, but you can it'll show you. Okay, this is your longitudinal wave.
What is a longitudinal wave?
Okay, that's what you want to look up. A longitudinal wave is actually how the sound travels, okay, from one place to another, and the molecules that it affects. So you always think that sound just goes from one place to another, but this is what's happening in between from when sound starts to where it goes, is that these molecules have to move in this fashion in order for that to happen, okay?
So did we save this?
So we have to move those molecules out of the way, yes. Now there's a way to read that. Go up above, go to the very top, okay? And it should tell you about some information. There's a way to search for information. That's an activity. Isn't that great? Now, if you wanted to prove that, I mean, here's a thought for an experiment for you, if you're thinking of something like that. Now, if that intrigues you, there are experiments that you can design to see. And you can try testing sound as it moves through the air, and then take the same thing and take that frequency and move it through liquid, and we have things to set up there, and then through a solid, and see what you notice. Okay? And the gas would be just as we do it right here. Okay? You wouldn't take someone's word for it. You would want to see if they're right or not, right? So that could be a suggestion you might want to tuck away. And by searching through these things, you'll come up with many other ideas based on what intrigues you with the information you find. And that's part of the reason why you also do these searches. Okay? As you get acquainted with information and read more, you can ask better questions.
The students discuss the information they have found with the rest of the class. They organize information and paraphrase it for their classmates. The class discussion gives the students the opportunity to reflect on and synthesize concepts they have learned. This demonstrates the interpretation stage of information processing.
So how many molecules would you imagine would be able to be affected this way?
Millions. Depends on how loud the sound is.
So, I mean, is it just going to be this small? I mean, like this? The size of my mouth?
Spreads out.
And what would allow it to expand?
The air.
The air, and also what?
The volume.
The amplitude.
All right. Probably the amplitude, right?
There's friction in the air, so eventually the force is going to diminish.
Okay. Eventually the force is going to
Theoretically, in space, the sound would travel forever.
Or never, because there's nothing to
That's
transmit
very
to.
good.
In space. Very good question. Would there be sound?
No, there's nothing for it.
But if there were sound, it would travel forever.
Because there are no molecules for it to bounce off.
That's what I like about 2001: A Space Odyssey. Like, in a lot of stuff, you see big explosions in space, and the Space Odyssey, there's absolutely no sound from it in space.
It's complete sound.
Like Star Wars, they have
Yeah,
big
exactly.
explosions and stuff.
And you hear, that was to give you the feeling that, like...
Could be produced, it would travel forever because there's no friction there. But then again, there's no polarity.
Yeah, that was actually a very, very good movie.
The students use Sound Edit software to learn more about the properties of sound so that they can design and carry out experiments. Sound Edit lets the students explore how variations in frequency and amplitude affect sound waves. The students are building background information in order to design their experiments. They relate what they learn from Sound Edit to their prior knowledge of sound waves. As they come to a better understanding of frequency and amplitude, the students can develop specific research questions for their experiments. These strategies demonstrate the pre-search stage of information processing.
And it works. No, if 400. I write about it.
Alright, what's your thing?
And then for this thing, it's 100.
Hey, Tone, get away. And make the screen vibrate. Oh god, we gotta try it. Alright, 800.
What are you doing?
We just find the tone. That's what we have to do.
So you have to go back.
We
We have to do it all at the same time.
have to find the tone. Yeah, find the tone.
800.
You know where it was? It was in that folder. I don't know why it was in there, but it was.
Hey, do you have Sound Edit?
I don't know how. We can have far removed.
It's just like a straight line.
What the heck?
Okay, let's do another thing. Oh, because you were like really low?
Look at that.
Oh, because it was really quiet.
It's too high.
Yeah, okay, let's do it again.
Too light.